Building bridges over the sea requires building columns in the water. How is this done? Here's the simple engineering method. It is natural that the splendor of the luxurious designs of the various giant water bridges in the world, which are erected over the largest rivers and seas in various parts of the earth, will draw your attention to the wonderful scenes that take the hearts, expressing the great urban progress achieved by architecture in the field of distinctive bridges. And far from the majestic visual scene of the huge water bridges, what was hidden was greater. How can the pillars and pillars of those gigantic bridges be with all this durability and strength while they are built in water? All these questions and more, we will get to know their answers together, to enrich our curiosity with brief information throughout the report, with the help of engineers with experience and specialization in civil engineering, in an accurate scientific manner, to clarify the above questions. In general, there are 3 techniques for building over water, and one of these techniques is chosen according to the conditions related to the work site, such as the type of sand under the water, the water quality, the weather conditions of the area in which the bridge is to be built, and the depth of the water. Temporary foundations are being built in the shallow waters on which the pillars, a type of pegs, will be built in order to support the upper structure. Thus, we note that nothing extraordinary was used to build the pegs in the water, and things are generally simple. Here you have another question, which is what if the water is too deep and the soil conditions are not supportive of building the pillars? In this case, the engineers resort to using different techniques in order to create the piles. Here comes the iron storage box technology. This technique is defined as a facility that sequesters water and sand in a specific area and can be implemented no matter how deep the water is. In this technique, a confined chamber is built under the water and is surrounded by water and sand. Then the excess water and sand are pumped out to make the area dry. You need to continuously pump water and other unwanted materials out. The walls of the steel storage box are generally made of lamellar piles supported by slabs whalers. So that the fund is considered a temporary facility and it is removed after the construction of the pillars supporting the bridge, and due to its temporary condition, its building materials are available in the form of molds. This technology is classified into 3 types. Reinforced steel storage box. It is a single wall of sheet piles that are placed in the excavated site in the ground and used in shallow waters with a depth of about 12 meters. Cellular steel storage box built in cell shape. This technique is used when it is not possible to use the previous technique supported box. In this technique, due to the forces applied to it, the storage box is stable. Double wall pedestal iron storage box. This technique has 2 rows of parallel lamellar piles which are driven to the site to be joined together by tie rods, and then the remaining gaps are filled with a material such as sand or gravel in order to complete the work. Drilling technique, in which the water is not ejected. In this case the chamber is against water leakage and air pressure is used to keep it out, then an airtight valve is installed to the water. After that, a special excavator is used to create a hole in the site, so that whenever the water level rises, air pressure is used to remove it. Then the previous hole is filled with concrete and left until ready. Then the columns or pillars of the bridge are built on top of these built columns. In the past, many human labors were employed to do this work, but now in modern engineering, the same work is done using advanced machines and equipment. Thus this is the primary mechanism used to build underwater columns.